Hello. Let's talk about the 5 transformations that we can make to the graph of a trig function. Let's start out with the sine function. We know what the graph of the first cycle looks like. Anytime we transform the sine function, we will locate those 5 points on the graph of our new transformed function. So let's see what changes are made to the equation and how they affect these 5 facts about our sine function: the amplitude, the period, the midline, and the phase shift. Okay, so the first transformation that you made in algebra is a vertical stretch or shrink. Well, in trig, we do that. It changes the amplitude. So the amplitude, remember, is the distance from the midline up to the maximum and down to the minimum. So here we say that A is 2. And remember, the amplitude is the absolute value of A. So this function y equals 2 sine x will have an amplitude of 2. That means the highest point will have a y-coordinate of 2. The lowest point will have a y-coordinate of negative 2. We have not changed anything else about the graph of sine, so it has a period of 2 pi. And if we remember then the sine function at the beginning of the cycle, the middle of the cycle, and the end of the cycle, the value of sine is always 0, so those points are on the midline. At the quarter point, which is after my first section, remember we divide it into 4 equal parts, is going to be up at the max, and then the 3/4, which is at 3 pi over 2, is going to be down at the min. So all I've done is changed the range of this function, which the range is now from -2 to 2. Okay, we do horizontal stretching and shrinking in trigonometry. We did not need to do that in algebra, but a horizontal stretch or shrink then changes the period, which is the length or width of the first cycle. Okay, so here, notice the 2 is on the x. So this 2 we refer to as b, and we say if b equals 2, then that is actually, we think of it as a stretch vertically, but that means it's a shrink horizontally. That means this function, y equals 2 sine x, makes 2 cycles between 0 and 2 pi. So to find the period or the length of one cycle, we take the period of the basic sine and we divide by b. So the period of this function, y equals sine of 2x, is pi. So it makes one complete cycle between 0 and pi. Everything else is the same: the amplitude, the midline, and there is no phase shift, so it begins at x equals 0. So that means between 0 and pi, if I divide that into 4 equal parts, each part is pi over 4. So sine begins on the midline. At the quarter point, it's up at the max. At the at the midpoint, it's back at the midline. At the 3/4, it's at the min. And at the end of the cycle, it's back on the midline. So it makes one cycle between 0 and pi. If I extended that out, then it would repeat that pattern in another pi unit. So I can see between 0 and 2 pi, this function makes 2 complete cycles. All right, vertical shifting. We did that in algebra. What does it do to our trig functions? It changes our midline. And for regular sine x, our midline is on the y-axis, which is x equals 0. So here, if this is sine of x plus 2, not to be confused with if the 2 was on the x, that would be a horizontal shift. So we're just moving our midline. So our midline now becomes the line y equals 2. Okay, so it's a horizontal line and the midline is at 2. Whatever the constant is, that's being added. And we refer to this 2 by the letter C. So C is 2, so the midline is always y equals C. So I can think of this as my x-axis. That's where my beginning, middle, and ending of my first cycle, or my cycle, will be, those points will be on that midline. So sine will begin, middle, and end have its points on the midline. Now the amplitude is still 1, so that means from the midline I'm going to go up 1 to get to the maximum, and down 1, whoops, that wasn't 1, fix that. We're going to go up 1 to get to the max and down 1 to get to the min. So my maximum or highest points will be at 3. My minimum value or lowest points will be at 1. So from that midline, I use the amplitude to get to the quarter and 3/4 point. So I go up 1 at my quarter point, and I go down 1 at my 3/4 point. So now I've got the 5 points on the graph of the first cycle of that function. Okay, then we can do a horizontal shift. Horizontal shifting, we call that a phase shift in trigonometry, but we did it in algebra. So what that says is, instead of my sine function beginning at x equals 0 or on the y-axis, we are now shifting that beginning point. And we know that if inside here it's x plus some number, we know that that is a shift left. So we are shifting that first cycle of sine left pi over 2 units. That means that if my original point was here, my beginning, I'm now going to the left to negative pi over 2. So this is where the cycle begins. Okay, so that point has an x coordinate of negative pi over 2. So we say that's the phase shift, or you can think of it as that's the first x value of my cycle. So the x would be negative pi over 2. It's where the cycle begins. Okay, so that means then where is it going to end? Well, this one still, because b is 1, it still has a period of 2 pi. So that means we're going to start at negative 2 or pi over 2. We're going to add 2 pi to get to our end. Where is it going to end? All right, so 2 pi we know is 8 pi over 4. So we have, oh, why did I get 4? Well, fix that. That would be 4 pi over 2. So negative 1 plus 4 gives me 3 pi over 2. So we divide it into 4 equal parts. Each part of my first cycle is pi over 2. So it's going to be, here we're at 0, that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So I'm ending here at 3 pi over 2. So notice, each pi over 2 increment is 1/4 of the period. Okay, so then I know then from here, I go up to my max, which is 1, because my amplitude is 1, and then I'll go down to my min. So I start by going up to the max, back to the, at the midpoint, we're back to the midline. Then I go to my 3/4 point, I'm down at the min, and then I'm back to the max. So we can see it's still divided into our 4 equal parts. We have our 5 points. The last transformation is reflections. Reflecting about the x-axis, remember, is when we multiply the function by a -1. So what does that do? Every point that's above goes below, and every point that's below the x-axis goes above. So now my sine function, remember, any point that's on the x-axis stays. So those 3 points on the midline stay, but at the quarter point, we now go down to the min first. At the 3/4 point, we go up to the max. So there's the graph of the first cycle of sine reflected about the x-axis. All right, in algebra, we didn't need to do reflecting about the y-axis because we could rewrite it and make it a reflect, or rewrite it, and we didn't have to worry about that with many of our functions, especially our even functions. But in trig, reflecting about the y-axis is not pretty. So what we do is we use the fact that the function is even or odd and we rewrite it. So remember, sine is an odd function, which means I can rewrite the sine of the opposite of x. If I take the opposite x value, put it into the sine function, I will get the opposite value of sine. So that's just the property of an odd function, any odd function. So I can rewrite this function as y equals the opposite of sine x, and what would have been a reflect about the y-axis can be rewritten as now a reflect about the x-axis. So we rewrite it, and then we know what the graph looks like, or we can do a reflection about the x-axis. So that's it. That's the 5 different transformations that we do. You've seen them with the sine function.